So, our final goal is to successfully make coconut macaroons. And for this, the materials we need will be 1.182 liters, or 5 cups of coconut flakes, 0.156 liters, or 2/3 cups of flour, 0.397 kilograms, or 14 ounces of condensed sweetened milk, 0.01 liters, or 2 teaspoons of vanilla extract, 0.002 kilograms, or 0.25 teaspoons of salt, measuring cups, cookie sheet with foil, and a mixing container. First, we need to measure out our flour and make sure we're not using too much or too little, because too much would create a thicker solution when we add our solvent, and too little would create an overly saturated mixture. Flour has two proteins called glutenin and gliadin, but these proteins will provide the structure to our macarons, as later, when we add our solvent, some of the proteins will form a bond with the solvent and create gluten. The gluten is the bonding agent of the coconut flakes, which will hold the macaroon together, as the gluten will form a network of woven protein strands, and that's what holds the shape together in the first place. However, we will not be allowing too much gluten to be formed, as the gluten will make a bread-like texture in our macaroons, which isn't necessary. Next, we'll add our coconut flakes, and in mixing the coconut flakes and the flour, we're creating a heterogeneous mixture. The coconut flakes are the main bulk of our macaroons, but they're not the actual solute. The flour is. In our coconut flakes, there's also a level of moisture and sugar that will react when baked to give the macaroons the flavor that's desired and the caramelization later. Next, we'll be adding the salt, which helps balance the sweetness and helps to enhance the other flavors. The ions in the salt will also interact with the amino acids in the flour and help give the macaroons an improved texture. It'll help it hold better. It also acts as a catalyst to lower the activation energy of the macaroons, because it increases the boiling point of the entire solution. So when I put it in the oven, I won't actually need to put it at such a high temperature that it could potentially burn. Now we'll add a bit of vanilla extract, as this serves not only to provide moisture and water necessary to react our solute, but it adds to the flavor and the aroma of the macaroons, which, in all honesty, even without the chemistry behind it, is pretty important, because no one wants to eat macaroons that are not aromatic or delicious. Now we're going to mix this mixture / solute and with the solvent in order to react all the flour proteins and sugars with the water that's there and create the proper consistency for our macaroons. Too much mixing though would be bad, because that could destroy the few gluten networks that we're even allowing to form, and would destroy the shape of the macaroons. They might just turn into a puddle of goo. But too little would not properly react all that can be reacted and will just create odd lumps instead, which would not be a good thing. And now we're going to form little balls, which will increase the total surface area of the macaroons and will speed up their reactions when they cook. We've already preheated the oven to 175 degrees Celsius, which also translates into 350 degrees Fahrenheit. This will be hot enough in order to evaporate the solvent and leave behind perfect macaroons with the perfect moisture and consistency necessary to actually be called macaroons. But since it'll be over 160 degrees Celsius, this is the perfect, well, not perfect. These are the proper conditions for the Maillard reaction to occur and to allow the tops of the macaroons to brown and for the flavor to be enhanced in the process. The macaroons will sit in the oven for 175 degrees at about 15 minutes as they undergo an endothermic reaction, and the water in them is evaporated enough to leave behind these moist and solid macaroons that we actually will get to eat. Hopefully. They're not charred, or brown, or black, or dying, or crisps. That would be bad. Let's not do that.